name's Nima, just graduated from Aerospace Engineering.
I'm Maria Barefoot. I also just graduated from Aerospace Engineering this past April as well.
In this last year, we had the pleasure of working on our project called LUMINEX for our capstone.
Yeah.
So there's three streams in the aerospace program here. We have the avionics stream, the aircraft stream, and the spacecraft stream. So the capstone courses are split based on the stream that you're in. So everyone in our capstone course was spacecraft. So obviously we do have a little bias in saying that spacecraft is the coolest one.
It's the coolest one by
Yeah.
far. LUMINEX goes back to the beginning of the semester. So it used to be an acronym for Lunar Material Excavation, and we can get more into that later, but that's basically what the original idea for the project was. And then as things kind of evolved with the project and the scope of it changed, we dropped the acronym and now it's just LUMINEX as the name, as a callback to the history of the project. But the name was charming enough for us to keep. To begin, an excavator is a big piece of machinery used to dig up a bunch of dirt and move it around. So we need one of those on the moon. Getting it to the moon is very difficult because it's super big, it's super heavy, and spaceships aren't that big and they can't carry that much weight to the moon all the way there. So what we did was we took the idea of an excavator with that big arm with the bucket, and instead we made it out of inflatable materials. So picture like a balloon animal. You blow it up in a tiny end, and then it becomes rigid in its form because of the air that's inside of it.
Originally, we started off with exploring the idea of having an excavator for lunar projects, mainly the Artemis missions that are going on, where they need to move large amounts of regolith on the moon. So we started with the concept of a lunar excavator, and what we realized throughout the project was that the loads were too great for any inflatable material to withstand, which was a necessity. So we shifted our focus in our project to how do we make inflatable material stronger, and that's what ultimately our project ended up becoming. So what we ended with was a model for an excavator, which we built, but mainly the most, I guess, crucial aspect of it, the most interesting part, was the reinforced inflatables that we had going on.
The original scope for the project was, we realized that within these Artemis missions, so the goal is to set up a lunar base for astronauts to go and hang out on for a while, with the end goal of eventually going to Mars. So it's like an intermittent step in that process. So in order to develop this lunar base, we're gonna have to have a bunch of infrastructure, and they're gonna need to move around a lot of lunar regolith. For a lot of the existing concepts for the Artemis missions, there's a requirement for moving huge amounts of this regolith, which is super, super heavy, in order to dig and dump regolith on top of other structures for radiation protection. There seemed to be an actual hole, like in the actual model, of how they were intending to do this, because on Earth you have excavators and you have gantries and you have all these massive large-scale metal equipment, but you can't transport large metal equipment to the moon because of like the weight and the size of it, right? Like in a spacecraft you only have a very limited amount of space to carry things.
The way that our system works is that the tubes and everything, the structure, the beams, they're all laid out uninflated, and they get inflated. Once they get inflated, they kind of take shape. So if you can just imagine the excavator, the beams, the large beams taking shape. And to strengthen it, once these things have taken shape, the epoxy resin kept at a temperature for it to be liquid would be pumped through these veins that we had running along these beams. And once they're pumped through, they will harden given the catalyst that's mixed into them. And once they harden, they become rigid, and now you have this beam that's now both inflated, and these veins that run along it are rigidized with the epoxy composite.
For us, when we started out this project, we were just given the task of, okay, so NASA wants to utilize inflatable materials for space solutions. Go and find something that can work, that can fit into this. So that was kind of tough for us at the beginning, because we had a lot of ideas. We had a lot of ideas, way too many ideas. So we had to just constantly go back and forth with the team to decide what we want to do, what we don't want to do, why one thing could be really cool but just impossible for us to design as undergrads. And eventually we reached kind of like a sweet spot with the excavator, because a lot of the courses that we had kind of like prepped us to be able to analyze it in elementary ways that you need to analyze these concepts.
And then obviously the challenge of figuring out that your idea doesn't work anymore. That was a huge setback, because that was half of the semester for us. that we had put all this work into and all this research into, and then we came to this head where it just wasn't going to work. You know, the design failed. So having to deal with that, instead we had to go back and start from square one. So that was a big setback for us time-wise. But that's a challenge that you'll definitely find yourself facing in the real world too. So it was kind of good.
Yeah.
It was good prep to learn that like failing and like having something not work is a huge step in the right direction of finding the proper solution.
Yeah.
So that was a major challenge for us as well, but one that I think was really, really valuable and kind of actually gave us ahead, like a good step ahead of the other teams in that respect as well.
Because I will say that I think the strengthened inflatable solution that we came up with is probably more valuable of a solution that we came up with as undergrads than the Lunar excavator itself.
I agree.
think,
For ours specific, this year around, it ended up being very structures based. So again, that's not always the case because the capstone projects change based on the year, but ours was heavily reliant on structures, and we took a class statics that I found myself using a lot, just like remembering like moments and reaction forces within structures and stuff. Linkages, that stuff, that was important.
That was a big course.
Yeah.
There was the introduction to space systems design.
Yeah.
That was a huge course. We had to make the solution for space, and that course basically tells you how do you make something that goes into space. What do you need to consider? How
do you get together with a team? How do you like start a project from start to finish related to space? Anything, right?
Yeah.
That was great.
Like what's the environment in space?
Yeah.
You know, like radiation, thermals, electricity, all of that.
All of that stuff. Yeah. Materials courses helped a lot. Those ones are always easy to hate, but very important.
Very important.
Especially if you're considering doing spacecraft, like space, any environment in space. Materials matter so much because the temperatures are crazy.
Yeah.
And like you have radiation and all this stuff. So materials courses. Yeah. Focus. Well, we're both staying in school. We're both staying at TMU actually, going into graduate studies. So we're both going into our masters in spacecraft, in aerospace engineering.
Yeah.
So it hooked us.
Also, TAs are really helpful.
Oh my gosh, TAs are life-saving.
They're angels. They can help you.
They want to help so bad.
Yeah, they make a course really enjoyable. They
do.
Can.
If you can use them as a resource.
Yeah,
and I've never had a bad experience.
Yeah, like they're also student. Like they were also just one students at some point.
Like
they're not.
Ago.
Yeah, like they
they're
feel like
these.
they feel like they're these scary ones, but they're not. One advice I would give is that just if you're ever like in a course and the prof's talking and it feels like it's just all going through you and you're not really understanding anything, just ask. Like it saved me so much throughout the courses where I would kind of bug the professor. I would just make sure that I really got it because I sometimes wouldn't. And then I found that to just be the most helpful thing because I knew that like if I knew I didn't fully get it and I kind of like went over it, I knew when the time would come like during a test or like an exam or something, I would be stuck just exactly where I was. So I found that asking that question during class it always helped me out in the long run.
What I always would tell myself is just don't be scared, and it's so easy to say and it's so hard to do, but for some reason there's just whole fear about like raising your hand and asking questions and asking for help when you need it and setting up meetings with professors. These are things that I didn't do in my degree at all. I never went and set up a meeting until I met him actually, and then he would do it all the time, like too much. And I'd be like, okay, if he can do it like 4 times a day, I could probably go talk to one professor once. So yeah, just like not being afraid and like knowing that you like have the right to be here and have the right to ask questions, and like you're paying for it, get the most out of your education and get the most out of these people that are trying to teach you, and they want to see you trying, you know? So I think that that's a lesson that took me a long time to learn. But yeah, I would say that that's like one of the things that would have helped me the most had somebody told me it earlier.